Welcome back to College Algebra, and we're doing our series on the basics of college algebra. And today we are thinking about fractions. And as we've been doing with much of this series, we're not so much talking about the things that would typically make up an algebra course, solving for x, graphing equations, things like that. Instead, we're talking about the basics, the underlying principles that you have to understand really well before you're ready to address college algebra. And today we're talking about fractions, a topic that's difficult for a lot of students. Let me say before we begin that we will do a lot of things today that you probably saw in elementary school or middle school. And I'm not saying these things to try to insult you. I'm not saying these things to demean you or belittle you. But instead, I'm doing it because these ideas are so critical to understanding how fractions work that they're worth reviewing, they're worth thinking through exactly what fractions are, so that when we come to doing more complicated things with fractions, we have this solid, firm basis. So it's going to sound pretty basic, but again, this is just meant to be a review to get us all on the same page. Let's begin by just today talking about what is a fraction really, and we're going to talk about this fraction 3/8 to begin. And I think you probably already know what a fraction is, but the way we should think about a fraction is we should think about a fraction as we have some object, and we have, the object could be a circle, and we've divided that circle into 8 pieces. 1, 2, and so if you look, I have 8 pieces of my circle. If I would have drawn it properly, each piece would be the same size. I'm not great at drawing, so a couple are a little bigger and a little smaller. But what is 3/8? Well, 3/8 is where we picked 3 of these, and so we have 1, 2, 3/8. And so this circle represents 3/8. So notice I have 3 out of 8 being represented by this circle. There's nothing magical about a circle. People like to use circles to draw fractions. We could have also drawn maybe something more rectangular in shape, divided it into 8 pieces, maybe something like this, and then we could have highlighted 3 of them, do something like 1, 2, 3, and then those 3 would have been 3/8 as well. Okay, I think you've seen these pictures and you're familiar with them, but I'm going to keep coming back to these pictures whenever we talk about new ideas, adding, subtracting, multiplying, dividing, simplifying, and then when we get into algebra and start doing things with fractions, we'll come back to these. But the first thing I want to talk about is I want to talk about the fraction itself and what the 3 and the 8 represent. First, the 3 is what we call the numerator, and the 8 is what we call the denominator. And you've probably seen and heard those terms before, but I want those terms to have a little bit more meaning today than we normally have. And so numerator, if you look at the numerator, you can see this num here. And what is num? It's something kind of like the word number, or to numerate, to count. And so the numerator always tells us how many of these things are involved. So we have a numerator, it says how many, and notice that in each time we counted 3. So our numerator is how many pi wedges? We have 1, 2, 3. How many squares? 1, 2, 3. So the numerator is how many of the group we have. Denominator, you'll see this phrase nom, or even larger, the phrase denom. Nom is a term that kind of means naming, or to name something. There are two terms in which we use the word denominate or denomination in our language. We use denomination, we talk about coins, and that is when we distinguish one coin from another by giving it a different name. We call it a different denomination, so we've separated them based on name. When we talk about churches in our modern society, we often call them denominations. What we've done is we've split all the churches up into groups, and we've called them by certain names. Denominating is kind of separating by name, and so what you'll notice is that your 8 tells us what type of object we're splitting up to. So I'm going to put this phrase here. It says denominator tells us what type. So if I look, what I see is I see that my numerator tells me how many. I have 3. My denominator tells me what type I'm working with. Now it's important to always keep this in mind, that the 8, we might think of that as some sort of calculating number, and it kind of is. We'll talk about that in a little bit. But really what it is it's a naming number. It tells us what type of object we're working with. Just for a moment, let me come up here and say, well, what if we had something different and we had, say, the number 3/6, then what I might draw is I might draw something that looks like this, and then I might highlight 3 of those. And what you see is that I have the same numerator as the previous problem. And so the previous problem I had 3/8. Let me get those out of the way. The previous problem I had 3/8. And so I had the same numerator. I've counted the same number of objects. With 3/6, I've counted the same number of objects. But the difference is that in the previous problem, I had 8 total. So the parts were each a 1/8 size part. Now each of these parts are a 1/6 size part. So if we change the denominator and keep the numerator the same, we have the same number of objects, but the type of object has changed. So our type of object here was a 1/8 size. Here our type of object is a 1/6 size. This is going to be important, especially when we get to addition, because one of the most basic principles we can come across in mathematics, especially in addition, is that you only add things together if they're of the same type. You don't add things together that aren't of the same type. And so we wouldn't add 6ths and 8ths together because they're not of the same type. And so what we do is we make them of the same type by finding a common denominator. And so that's why we have to find the common denominator, because 6 types and 8 types are different, so it doesn't make sense to combine them. We'll talk about that in much greater detail when we talk about addition. One more example I'd like to discuss is an example of 2 1/3, and this is just what we call a mixed fraction. We have a whole number, 2, and then we have a 1/3 combined with it. You'll know that we can rewrite this as a single fraction, but where the numerator is larger than the denominator, and we'll do that in just a minute. But first, let's talk about what is the 2 1/3. Well, 2 means we have 2 of these objects here. And then the third means that we had an object and we split it into thirds. And so what is our amount? Our amount is this block plus this block plus this 1/3 block. Now if we want to rewrite it as a fraction, what I should probably imagine doing is splitting each of these blocks into thirds. And what you'll see is that I have 1, 2, 3, 4, 5, 6, 7 thirds. Is my total, my 7 thirds. Now, what's the quick way of thinking about this? A quick way of thinking about it is that 2 here is equal to 6 thirds, and I did that by just multiplying 3 by 2 to get 6, right? So notice that if we have 2 objects and we split them into thirds, we're going to get 3 here, so we would get 6 thirds. And then we have 1 additional third, so 6 plus 1 gives us our 7 thirds. So anytime we have these two types of discussions, if we have a fraction written as a whole number in a fraction, or a fraction written where the numerator is larger than the denominator, we can use either form, and both forms are the same, and both forms are interchangeable, so you're free to choose either one. The last note I'd like to say about fractions is that we can often think about fractions in terms of division. And if you think of the number 1/4, what does that mean? Well, on one hand, it means that you have a block, you have 4 objects, you have a whole, and we split that whole into 4 pieces, and we selected one of those 4 pieces. So in some senses, that's what 1/4 is. But if you notice, that's also what division means. So division means you split your object into that many pieces. So remember, if you have, say, 12 divided by 4, you took your 12 objects and put them into 4 groups. The only difference is now we had 1 object, and we need to put it into 4 groups, and so our groups are each just 1/4 of the object. So it's always important to keep in mind when we think about division, to remember that, when we think about fractions, to remember that we could interpret it as division, because it's very useful to think of fractions in division terms. And by the way, if you were really motivated, we could write this with 1, and then we could put the 4 on the outside, and we could do long division to find our answer. We would need to put a decimal here, and then we'd go 2 times 4 is 8, subtract, and we would get 2, we'd need one more 0. 0, oh, that's not meant to be a 0. Then we need a 5. 5 times 4 is 20. I forgot my decimal, and so our answer is 0.25. And so you see that 1/4 is the same as 0.25. And we do that by just doing the division, taking the 1 on the inside and the 4 on the outside, and doing our long division. And then if you don't make a mistake, like I did, you get the correct answer. So that being said, it's important to be able to think both ways. By the way, I know that all of you knew that 1/4 and 0.25 were the same to begin with, but if we're in more complicated situations, we can always think of our fractions in terms of decimals if we want by thinking of them as division. All right, thank you very much. We'll come back next time and talk about simplifying fractions, and then we'll move on to other operations.